Hi guys! Welcome to another video for C410 or hydraulics. At para sa video na to ay mag-solve tayo ng problems about unsteady flow on orifice. So sa mga hindi pa nakakapanood ng aking lecture or ng concept about unsteady flow on orifice, ilalagay ko yung link dun sa description dyan sa baba. Let's go! Let's go! So ito yung problem. Problem number 14, a 150 mm diameter sharp edge orifice with coefficient of discharge C is equal to 0.75 is located at the bottom of a cylindrical tank with dimensions of 3.5 meters high and 1.2 meters diameter as shown in the screen. So the tank is filled with water. If the initial level of water is at 3 meters level before opening the isolation valve at the orifice, what is the time required for the water to reach the level of 0.5 meters from the bottom of the tank when the valve is open? So let's understand the problem first. So meron tayo dito ang open tank. So ito siya. Since open yung tank natin ay wala tayong any input gauge pressure dito sa loob ng tanke. So yung height daw nung mismong tank is 3.5 meters at yung diameter ng cylindrical tank is 1.2 meters. So initially daw, since wala naman sinabi sa problem na merong inflow or meron tayong supply ng liquid dito sa loob ng tank. So initially 3 meters yung height ng water sa loob ng tanke. Kapag ka hindi pa binubuksan yung isolation valve dito sa opening o dito sa orifice na located dito sa bottom ng tank. So ngayon, ang tanong, what if buksan natin tong valve or itong isolation valve? So since binuksan natin to, ang mangyayari ay magdi-discharge tayo ng liquid. So magdi-discharge tayo ng water dito sa opening at yung head natin initially is 3 meters ay bababa siya. At kailangan daw nating ma-reach yung height na 0.5 meters. So, ang tanong, ano daw yung time required? So, the required is ano yung time required if yung final height natin nung head, denote ko na lang siya as h sub 2, is equivalent to 0.5 meters. Knowing na given naman yung diameter ng orifice which is 150 millimeters at yung coefficient of discharge na 0.75. Let's go! So ngayon, since falling yung head, at hindi natin ma-maintain itong initial height which is 3 meters, yung flow is unsteady. Meaning, at any point of time ay nagbabago ang discharge o yung flow rate dito sa orifice. So ngayon, ang una nating titingnan dyan ay yung cross-sectional area ng tank. So, kung mapapansin nyo, ito ay cylindrical tank. So, ibig sabihin, yung cross-sectional area niya is constant all throughout the height. So, kung ano yung cross-sectional area nito o yung area ng surface para dun sa tank at height 3 meters hanggang dun sa required which is 0.5 meters ay same lang din yung cross-sectional area. So, at this case, gamitin natin yung derived formula. So, that is T is equal to 2 A sub S or the cross-sectional area of the tank all over cow o coefficient of discharge times the cross-sectional area of the orifice times the square root of 2g multiplied to the square root of the initial height which is denoted as h sub 1 minus the square root of the final height which is or the final head which is denoted by h sub 2. So, given na yung C, yan, makakompute naman natin yung E sub S and E sub O. Given na rin naman tong h sub 1 and h sub 2. Wherein h sub 1 is equivalent to the initial height, which is 3 meters. So, ngayon, compute muna natin itong dalawang cross-sectional areas na to. So, for the tank or for A sub S, that is pi d square over 4. So, since pi d square over 4, that is pi times the diameter of the cross-sectional diameter is 1.2 meters square over 4. So, input natin sa calculator. So, that is pi multiplied to 1.2 square over 4. So, that is 1.13097 square meter. So, ang gagawin natin ay store natin to sa calculator. So, shift store. So, sa A natin ito ilagay. So, lagay ko dito A. So, okay na tayo doon. Next, yung para naman sa cross-sectional area ng opening ng orifice. So, that is A sub O is equal to pi d square over 4. So, that is also equal to pi times yung diameter ng opening, which is also equivalent to 0.15 meters. Dapat naka-meters tayo. 0.15 square over 4. A sub O is equal to, so, binalik ko lang, input ko lang sa calculator, palitan ko lang to ng 0.15. So, that is 0.0177 square meter. So, gawin ko ulit, mag-store ulit ako. Store ko naman to sa B. Ayan. So, lagay ko dito ay B. Ayan. So, pwede na nating i-input to, mga values na to sa ating formula. So, bago ulit ako ng 10. So, pag sinubstitute na natin to, mga values ay, this is 2 times A sub S, which is na-store na natin sa A, all over C, which is 0.75, multiplied to A sub O, which is store na natin sa B, multiplied to the square root of 2G. 2 times 9.81. Then, yan. Multiply natin itong buong function na to sa square root of H sub 1, which is the square root of 3, minus the square root of H sub 2, which is square root of 0.5. Ayun. So, input na natin sa calculator ulit. So, this is 2 multiplied to alpha A. Then, 0.75 multiplied to alpha B. Multiplied to the square root of 2 times 9.81 multiplied to the square root of 3 minus the square root of 0.5. So, ang answer natin ay 39.49. So, yung answer natin dito ay in seconds. Kasi kung mapapansin nyo, ang function lang natin ng time dito ay nandito sa G. Oh, wherein yung unit natin for G is meters per second square. So, ayan, once na ma-evaluate na natin, lahat ng values na to ay in terms of seconds yung makukuha nating final answer. Ayan, wag na rin kayo malilito kung paano ba pumili ng H sub 1 and H sub 2. So, ang reference lagi natin ay yung location ng orifice. Yun yung magsisilbing datum line natin. So, in this case, kung ito yung datum line natin, nag-start tayo sa 3 and nag-end up tayo sa 0.5 meters. Let's go! At yun lang para sa video na to. Sana may natutunan kayo at see you sa next video. Thank you so much.